Actually, I don't think I know.
So, step 1, FOIL, 15x cubed. Outer will be 12x squared.
That's 10x.
And the derivative.
100x cubed plus 24x.
What'd you see? What'd you say?
100x cubed.
100.
Oh crap, it's 4. It's minus 1.
Come on, dude.
Seriously?
Seriously, dude?
24.
Okay, any questions so far? Okay, then number 2 asked you to create a function that a power rule would not work on.
The absolute value of negative x squared.
Okay,
Oh, wait.
what else? Sine or cosine? Which we know a rule for sine. What about x times the sine of x? We don't have a rule for that because it's got multiplication. Now this one up here was multiplication, but we were able to multiply it out. So today we're going to learn a rule, logarithms. So we know we still have lots of rules to learn. Today we're going to learn a rule that allows us to find the derivatives of products and quotients, things that are multiplied together, and things that are divided.
Well, we have to work one long ways on it.
Yes, one.
Only one?
Only one.
Okay, I'll deal with that.
So is the test a bunch of shortcuts and one long way?
Yeah. Pretty much. I mean, we got some work ahead of us, but yeah.
When is this test?
We've got a while.
A couple weeks.
Yeah.
2 weeks.
Give that a look.
Okay, so the product rule, I do want to show you the proof of the product rule. You will never have to recreate this proof. It's just for you to see that it works. Anytime we have a function that we want to find the derivative of and we don't know how, we have to go back to the long way, right?
Yeah.
So this is the long way for f times g. With some very clever mathematics, and again, you don't have to come up with this. If you add and subtract into this red part, how it's added and subtracted is the same thing, added and subtracted, which is legal to do, right? If I want to add and subtract 3 for some weird reason, I could. Be silly most of the time, but then you could factor out of the first 2, you could factor a g of x plus h out, and out of the second 2, you could factor an f of x out. With some rearranging, that gives you the derivative of f times g of x as h approaches 0, and f times the derivative of g. So here's our shortcut.
So now we're going to forget about everything and just stop there.
That's fine with me.
Yeah! I never learned anything up there, so I don't know what you did.
There are a few people who probably enjoyed having that because there are some people who need the why to be able to do it, and that's the why.
I need the one.
Skip.
Okay. That's fine.
That last line.
But the last line is the shortcut of the derivative of a product. If I have f of x times g of x, the derivative of that is f prime times g plus f times g prime. Or we're going to use a little shortcut in our head and go lefty right plus righty left. Left, derivative of the right, plus right times derivative of the left. Or you can do it backwards, it's plus in between, so it doesn't matter. Lefty right plus righty left. Catch it. Left derivative of the right plus right derivative of the left. Or you can, it doesn't matter which order because it's plus, so lefty right plus righty left.
Okay.
And this is the official product rule, but it just says left times the derivative of the right plus right times the derivative of the left. Right, it's just the product rule. I do want you to know that a product rule can be extended to multiple products. most of the time you won't have to do this, but just mental note, it's really easy. If you ever have f times g times h, so 3 things multiplied together, to do that derivative, you do the derivative of one and leave the other 2 alone, plus the derivative of the next one and leave the other 2 alone, plus the derivative of the last one and leave the other 2 alone. So that's an extension of the product rule. I would write that down. It's not something you will have to use often. In fact, you may have to look it back up the next time you want to use it because it's not something you'll use that often. But if you ever needed to extend a product rule to multiple products, that's how you do it. Any questions about that one? You don't have to write all the words down, just write the rule. Okay, the next thing we're going to talk about is the quotient rule. I'm not even going to show you the proof. It's very similar to the product rule proof, but it's just another rule we're going to follow. So the only thing you need to write down is the bottom, this thing. This thing right here is what you need to write down. The derivative of a quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And I'm going to give you a way to remember that one too. H-I-G-H, but we're going to shortcut it. Okay, you have the top function and the bottom function, the high function and the low function. The derivative is low d high minus high d low over low squared. So, yeah, like the denominator, the bottom. So low d high minus high d low over low squared. It's just another memorization tool. It's quite helpful though. Low d high minus high d low over low squared. Does this one matter which order you do them in?
Yes.
What's the difference? When I said product rule, it didn't matter. This one subtraction. The product rule was addition, so it didn't matter. But this one you do have to do low first. Bottom times the derivative of the top minus top times the derivative of the bottom. I want to do this one first to remind you that just because we have a quotient rule doesn't mean we always want to use it. And then we'll do some that we have to do a quotient rule on. Do I have to use a quotient rule on this? Why not? I can divide it. In my AB calculus class right now, half of them, when they saw this, would do the quotient rule. It would take them much longer, but that's what they would do. So I just want to point it out that don't forget, if algebra simplifies it, then it's easier. This is option number 1, is to rewrite y. This is my preference on this particular problem. What happens to the 2/3? Then I get negative 5/3 x to the negative 2, and I'm done. But just for fun, we're going to learn the quotient rule. The derivative. What do I do first? Low. So I just write down the bottom. D high. Well, what is the derivative of the top?
2.
2. So low d high, the derivative of the top, minus high d low, which is all over 3x parentheses squared. I'm going to simplify that. This is 6x minus 6x minus 15. Why is that 15 negative? Distribute the 3 and the negative over 9x squared. 6x's cancel, and I get negative 15 over 9x squared, which reduces to negative 5 over 3x squared. So you notice I got the exact same thing. You could argue with me. I would argue algebra was easier than quotient rule. So using algebra was easier. If you can, still use algebra. When could I not just divide this out? Okay, if there were a square root involved, definitely. If the bottom had a plus, can I split that?
Oh, no.
So if the bottom had more than one term, I would have to use a quotient rule. So quotient rule is necessary, but not always. Okay, so we're going to practice doing some derivatives. We now have some new rules. I agree. We do not have to use a new rule on this one. Why? Yeah, I could just FOIL. Now, what if the right-hand piece were maybe a trinomial or 4 terms? You could still distribute, but then it might be easier to do a product rule. Does everyone kind of know what I mean by that? There is a time when a product rule would be easier. This is not it. That makes sense? First, outer, inner, and last. And so the derivative is
24x squared.
So you may be wondering, Ms. King, if we're learning these new rules, why are you doing things without them? Well, I am trying to overemphasize. If you can do algebra first, it's going to be easier. The rules are great. We will use them if we must. On the next one, can I avoid the product rule? No, because there is no way to make this just into a power rule. It's x to the 4th times sine of x. And if you're wondering whether you need a product rule or not, read this with the symbol in between. If you have to say times, then yes, you need a product rule. If it's any two things multiplied together, you need a product rule. The only exception is a constant in front. Do you have to use a product rule for a constant in front? No. Now we learned we can just bring the constant down, but anything else? So, to do this derivative, I have to do left times the derivative of the right. What is the derivative of sine of x? Cosine of x. Plus right times the derivative of the left. What is the derivative of the left? The only thing I would do as far as simplification is I would never leave a polynomial written after sine of x, because you might accidentally be tempted to multiply those x's together. But remember that x is trapped inside sine, so if it were me, the only thing I would do is rewrite this to be 4x cubed sine of x. Okay. So that's product rule. So you've seen a product rule, you've seen a quotient rule. That's the big new stuff for the day. Questions so far? On which part? So I did, this is left and this is right. They're multiplied together, so I have to use a product rule. The left derivative of the right, right derivative of the left. That you're good now? The product rule. this yellow thing. I don't mind. And the shortcut saying to that is left D right plus right D left. If you like shortcuts, or you know, if you like those memorization wording things.
At first, I thought you just like added the D for sound.
Yeah.
Harmony.
It does sound good, though, doesn't it? Left D right plus right D left. Alright, let's look at these two.
Whoa.
There is. Since there is a plus on the bottom, what does that mean?
Whoa.
I can't just use algebra. I've got to use the quotient rule. I would still do a little bit of algebra rewriting. I would change that x to be an x to the 1/2. Now, if this were flipped the other way,
You could do it.
I could divide and I could do it. But with the plus on the bottom, I am stuck and must use calculus. Must use the quotient rule. So, quotient rule is low D high. What is the derivative of the top?
1/2 x negative.
Any questions about that so far? So that's bottom derivative of the top.
Where could the D be loose?
Derivative, yeah.
Stupid.
No, you're not. That's why there's that's why the whole thing you've written out is important too. But it is nice to have a way to memorize it though. And remember, that's just a memorization tool to help you know which part goes where.
Quick call to the high school office, please. Maya Wong and quick call to the high school office.
3x squared.
Okay, good. Low D high minus high D low, which is 3x squared, derivative of the bottom, over the bottom squared. Now, if this fell on open response and it just said to find a derivative, you'd stop there because we did. If this were on multiple choice, it probably would be simplified. So I'm going to go through some nasty algebra simplification. This part would be to match a multiple choice answer. First thing I'm going to do is distribute this to both the 1 and the x cubed.
Wait, you can't just cross out one of the x cubed plus ones?
No, because there's not one with both.
That's nice.
Yeah, there's a subtraction in between.
Hey, where are the purple ribbons?
They are in third hour. They're going to start on Monday doing a competition for Relay for Life. Remember the bows from last year?
That's what you do.
Okay, so I'm going to multiply 1/2 x to the negative 1/2 by both pieces. When you're multiplying two things at the same base, you add exponents. So I get 1/2 x to the 2 1/2, which is 5 over 2. Any questions about how I got that? Plus 1/2 x to the negative 1/2. The 3 and the negative 1/2 added together, because you add exponents when you have those. And so you get 2 1/2, which is 5/2. It would, I haven't finished. This is just this piece. This is just those two. Minus 3x to the 5/2 again, 2 1/2 again. Then I could combine like terms. So those two combined together to give me 2.5 again, or 5/2 again, right? 5/2 x to the 5/2
Oh.
plus 1/2 x to the -1/2 over x cubed plus 1 squared. Again, at any point, if this was or open response, we would have been done from the beginning. We found the derivative a long time ago. Everything I'm doing from here on out is only to match multiple choice answers. The only time you would do it is if you're looking at multiple choice to pick out. Does everyone know what I mean by that? I'm going to continue going because a lot of times multiple choice is ultra simplified.
How did you get from the second to the third?
From here to here? This, combine those two. Oh, but that should be negative. Sorry. Combine this term here and this term here. But I'm glad you asked because I almost missed a negative. Okay. I'm going to do a little bit more simplification. I know you won't like it, but again, we are only doing this if we were needing to match a multiple choice answer. Any ideas on something I could do that would simplify things? What makes this look nasty? The fractions.
The numbers.
The fractions, maybe the exponents as well, but definitely the fractions, right?
Could I have your attention, please? If there are any morning onesies that have their pen and down forms ready, would you please bring those to the office? Thank you.
Couldn't I multiply the top and bottom of the fraction by 2? Does that simplify it a whole lot just right there?
Yes.
Because I don't have fractions inside of fractions, although technically I still do because of that x to the -1/2, which brings me to one other simplification you could do. Again, what's the only reason you would do any of this? Only if the multiple choice didn't match your answer, you could try to match. We're only multiple choice answer matching. So on your homework tonight, do you have to do this?
No.
No, only you only have to do this if you're trying to match a very simplified multiple choice answer.
We're going to get a calculator.
No.
Sir.
Okay. The one other thing, isn't this an x to the 1/2 on the bottom? Isn't it? So I could also multiply every piece by x to the 1/2 power to get rid of that denominator as well. What is x to the 5/2 times x to the 1/2? You add, right? X to the... So, well, that's not with the x. That's with the -5. So it'd be x to the 6/2, which would be x cubed. I'm sorry. And I would say don't unless you must. Say that again. This, what, you mean why is the -5 there? Because I didn't change it, I just put the x to the 1/2 in. It's not the same thing, so I can't. Okay, so that was fun. Maybe not, but again, is that something you have to do every time you do a derivative?
No.
No. But now this one's a lot easier. Okay, can I simplify it with algebra?
Question.
No.
No. Oh, find the derivative still.
No.
I can't because it's cosine. Now, one thing you could do is you could turn it into a product rule. I'm not going to, but you could turn it into a product rule. How could you turn it into a product rule?
Make that x to the negative.
You could make that x to the -2 times cosine of x. A product rule is not enough easier than a quotient rule that I'm going to make that decision here, but if you wanted to, you could. So you could change this into a product rule. But I'm just going to go ahead and do quotient rule. Is it really cold? Are y'all freezing? The consensus was a no. We'll leave it for another minute or so, and then we'll turn it up. I think I'm overexcited. My air conditioner's been broken for 3 days, and in 6 and 7 hours it's been really hot in here. And so I think I'm like, it's working. Let's leave it on. They fixed it this morning. It's exciting. Low, yeah, sorry. My air conditioner was broken. Low, D high, what's the derivative of cosine of x? Minus high D low over low squared. The only simplification I'm going to do on this...
Are you derivative? Did you leave that as your answer? But you moved the 2x.
I'm going to move the 2x to the front. I'm actually not going to do any more simplification on this. There is one thing that could happen. There is an x with everything, so you could have x sine of x minus 2 cosine of x over x cubed. So that's the only simplification you could have. On this one?
Yeah.
The derivative, yeah. Yes. 10 after, right? I think that's what I said just a second ago. Was divide everything by x. Everything has an x in it. And you could do that. You don't have to, but you could if it were to match multiple choice. We do get out at 10 after. All right. How many times would you have to use the product rule or the quotient rule to find this derivative? I want to know not how many I can use, how many do I have to use a product or quotient rule? Sorry. How many times must?
1,
2, 5.
I'm sticking with 1.
Why 1?
Because it's
This is the only one that I can't simplify, right? All of the others I could do some sort of division. So, 1 time.
I thought that I got dyslexic. I missed the second one.
Okay. Common AP problem type to get... Hey. Common AP problem type to challenge your knowledge of rules, derivative rules, is a problem like this. It says A of x is L of x times W of x. Find A prime of 4. Well, how would I find A prime of x?
product rule.
Product rule, right? Because of the derivative.
Why so many words?
Okay, so I'm going to do left times the derivative of the right. Pretty much I'm just writing the rule, right? Plus right times the derivative of the left. And then how would I find that at 4?
Plug in 4 for x.
Plug in 4, so I get L of 4 times W prime of 4 plus W of 4 times L prime of 4.
So prime and derivative are the same thing?
Yes.
Differentiate.
Yes.
Really?
Well, differentiate is the verb form of find the derivative.
Why can't we just say derivative?
Do what?
Okay, do I know L of 4?
2.
How'd you know?
Because it's starting.
Because table says. So again, very common AP problem type to use tables like this. W prime of 4 would be -1.
1.
W of 4 and W prime of 4.
4.
L prime of 4. That makes more sense. It is 4. Y'all said the right answer. I asked the wrong question. Negative 2 plus negative 12 is negative 14. Now, you could do a lot of this in your head. You wouldn't have had to show all that work, but we're new at this. Hey, we did that yesterday. This is not a bell ringer. Yeah. I want to find the derivative of secant of x using a quotient.
1 over cosine of x.
Oh, can I now do all of the trig derivatives? Can I?
Unfortunately, no.
Low. D high, what's the derivative of 1?
0.
Minus. High, what's the derivative of cosine? All over low squared. So sine over cosine squared, which is often written as 1 over cosine, which is secant, sine over cosine, which is tangent. So the derivative of secant is secant x tangent x.
Where'd you get y sine x?
This one, cosine times 0 is 0, and then negative times a negative.
I thought cosine of 0 is...
It's not of 0, it's cosine of x times 0.
Oh.
And anything times 0 is...
Well, then shouldn't it be negative 1 times... Shouldn't it be sine of it, though?
Because it's negative sine, bro.
Come on, bro.
Hey, let him ask questions.
That's a good question. You let him ask the thing when you realize the answer.
Okay. We could do them all that way. But we could just do them once and memorize them. And so I did them for you. We did secant of x together. We could do tangent by doing sine over cosine. We could do cotangent by doing cosine over sine. Or you could just memorize them. You could probably tell what's on your next mastery exam. Probably lots of memorization of derivative rules. The derivative of tangent is secant squared. The derivative of cotangent is negative secant, cosecant squared. The derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. Really quick mental note. If the trig function has a co in the front, its derivative is negative. To help you memorize which ones are which. What's the derivative of cosine?
Negative.
Negative sine. The derivative of cotangent is negative cosecant squared. And the derivative of cosecant is negative cosecant x cotangent x. So just to help you remember which ones get negatives, all the ones that start with co, try to point out anything I know to help you memorize. Anything I can think of that might help. Do you have these written down? We'll do some more examples tomorrow. You need to write down this little table here because you'll need some of those rules on your homework for tonight. And we've got, this is not all due by any means today at all. Not even close. You can do it. I'll remind you so you don't have to do all of it at once. I do need to find the actual.
True wise are good right there. True, why do you even sit there?
I don't know.
I grabbed the product rule homework earlier today.
You couldn't breathe underwater.
Let me see. You need a worksheet.